Hello everyone, my name is Nathan Bransby. I'm honoured to be joining you from Western Australia. Please welcome our next speaker to the stage, Azul Garza. Azul is the co-creator of the Nixtla verse and TimeGPT. She is considered to be a leader and expert across AI and machine learning domains. Her research and experience has earned her to receive prestigious awards and be invited to speak to many conferences. Please give a round of applause as I welcome Azul Garza to the stage with her talk, TimeCopilot, the GenAI forecasting agent.
Hello everyone, thank you so much for attending this session, and thank you so much to all the people that made PyLadies 2025 possible. I'm very excited and very grateful to be here with you all. My name is Azul, and today I'm going to talk about TimeCopilot, the open source project where large language models finally, I would say, meet time series foundation models. A little bit about me before getting started. I'm originally from Mexico and now I'm based in San Francisco, California. My pronouns are she, her, and apart from being a huge Python fan, I'm a time series fan. I've spent the last decade building open source tools and models for forecasting. I helped create one of the largest open source time series ecosystem in Python and co-authored the first foundation time series model. And I have more than 10 years of experience working with time series, with Python, in the forecasting field. And now I'm building TimeCopilot, the GenAI forecasting agent. And with this project, everything started with a question. What is the future of forecasting? How does the future of forecasting look like? But before that, let's answer a simpler question. What is forecasting? Just to have a common understanding of the things that we will be discussing in this session. And I like to define forecasting by defining time series, which in my understanding is numerical data ordered through time. So imagine, for example, that you are following the number of views that your favorite singer has on their Wikipedia webpage, and you collect that data. Then you will have a time series. Here, for example, we are seeing the monthly views of the webpage of Shakira, Selena Gomez, Lady Gaga, Taylor Swift, obviously, why not? And the goal of forecasting is to predict the future, to understand it better. That's the forecasting problem. In a nutshell, we want to paint the right side of the plot, and if possible, to have an understanding of the uncertainty associated to those estimations, thus the interval around the point or mean forecast. And it has a lot of applications: macroeconomics, finance, manufacturing, supply chain, retail, and the list can just go on and on. If it is a very important problem and it has a lot of application, how has it been solved so far? And we can find in the literature different approaches. From the statistical ones, we take advantage of some characteristics of the time series, for example, the trend, the seasonality, the stationarity, for example, AutoRima, AutoETS, Theta. Then we have more modern approaches that uses some machine learning models such as like GBM, linear regression, among others, and you need to rely on creating features to be able to use them. And in the deep learning literature, we can find some specifically designed models for time series, for example, NHETS, NBETS, LSTM, among other models. So the question that usually a forecaster wants to answer is which model should I use? Which model should I should be using in production? And usually a forecaster relies on pipelines, feature extraction to understand the data better, model selection using time series cross-validation to select the best model, then forecast generation, and finally deployment. A new paradigm has arrived in the recent years, foundation models. And basically, they are a mimic of the large language models. You have a usually large model and you want to pre-train it using an usually, again, large data set. But in this case, the model and the data set are adapted to time series. So you have a particular time series model and you pre-train that model on a time series dataset. And once it is trained, you can use it to generate forecasts over a new set of time series. That's the idea behind time series foundation models. And we have seen new approaches being developed in the next year. In the past years, starting from TimeGPT 1 by Nixtla, then new ones have emerged. For example, Chronos by AWS, Moirai by Salesforce, FlowState by IBM, Tyrex by NXAI, Toto by Datadog, Sundial by the Tsinghua University, and probably we will be seeing a lot of new approaches in the years to come. So the problem still persists. Which model to use? And maybe the answer is again on pipelines, feature extraction, model selection, forecast generation, and deployment. And at the same time, in the broader AI space, we have seen an explosion of agents, and they are being used on image, text, video, audio applications. They are everywhere. They are automating pipelines. They are writing code. They are running tasks autonomously. We have products like Gemini CLI, AutoGPT, Baby AGI, Devin. Where are the forecasting agents? That's one of the questions that drives TimeCopilot. And this question, I think it's very important for the forecasting community, but also for me personally, because forecasting has this huge impact. It requires a lot of technical knowledge, but there has been little agent-based experimentation in the field. Yet it's a perfect fit because you need to select models, run error diagnosis, data cleaning, code generation, a lot of the steps that can be automated. And that's how TimeCopilot was born. In a nutshell, TimeCopilot is a generative agent written in Python that solves the forecasting problem systematically using large language models. It can interpret statistical features, it can guide model selection, it can explain technical decisions just in plain English, in natural language, and can answer domain-specific questions about forecasts. Here you can see the architecture behind TimeCopilot. We have a time series model hub as the first layer of the project, and we include models from foundational ones to statistical, machine learning, and deep learning ones. And also we have an LLM layer, and we support basically any LLM supported by PydanticAI. And TimeCopilot automates this workflow of generating features to understand the data better, then selecting some models to cross-validate them based on this understanding of the features to select the best model, and finally generating forecasts. Once the forecasts are generated, it can analyze them and explain them using natural language. Here we can see an example of a user asking how many passengers are going to be in the coming year using natural language and getting the answer in the same language. It has, as I mentioned, different features. One of the most important ones is that it achieves the first place in the GIFT-Eval benchmark amongst open source implementations. So it's better than Chronos, TimesFM, Flow State in different labs from AWS, Google, IBM. So let's go live. You can install it using UV TimeCopilot. And if you enjoyed this presentation and you want to support this project, please give us a star on GitHub. We will be very grateful for that. So to start working with TimeCopilot, you just need to UV run TimeCopilot. You need to have the package previously installed. You can achieve that using UV at TimeCopilot. And just like that, you will have access to this terminal and you can start asking questions about the future of your data. So for this particular example, imagine that you are interested in knowing the future views of a web page on Wikipedia. Let's say Christmas because it's December. So you can start asking questions about that using plain English. In this case, I stored the dataset in this path and I'm explaining just using natural language what the dataset contains, which in this case is monthly views of the Christmas web page on Wikipedia. And using, again, just English, I'm asking about the future, how many views it will have in the next six months. And just like that, the agent will read the data. We perform all the pipeline, which consists on selecting some features and calculating them to understand the data better. After that, selecting some models based on that understanding to cross-validating them and select the best one to finally generate some forecast. Behind the scenes, all this is being done by the LLM. And just like that, we have an answer. And TimeCopilot gives us the forecast for each one of the next months. Obviously, we can continue asking questions about these results, and even we can see the plot of the forecast using just natural language. For example, show me the forecast plot. And behind the scenes, it will generate the plot and show that. As you can see, because of December, it detects this peak in this year. And also we can detect anomalies of the data. Are there any anomalies? Please plot them. And TimeCopilot also can detect those anomalies and can give us some understanding about the anomalies using just plain English. Obviously, if you are a seasoned forecaster and you want to connect this agent with other agents, you can do that using just Python. In our documentation, we have some examples in our getting started web page. Here, for example, using a Jupyter notebook, we show how you can interact directly with the agent using just Python. So you can start querying your forecast using Python and connect that to other processes. And also, if you want a lower level of integration, namely you want to run your own models, your own foundation models, you can do that directly using TimeCopilot. And the greatest, or one of the greatest advantages of TimeCopilot is that you can run different models, different kind of models through an unified API. So for example, if you want to run AutoArima, AutoEDS, and also some foundation models, for example, Moirai, or Chronos or even TimeGPT, you can achieve that using an unified API. Here, for example, we are generating forecasts for different models. So as you can see, TimeCopilot is a complete framework that allows you to interact with LLMs, foundation models, and other kind of models. If you like the project and if you enjoyed the presentation, please give us a star on GitHub. That will help us a lot to continue developing this project. Thank you so much for watching. See you soon.
Azul, thank you for teaching us about forecasting and the many ways TimeCopilot can assist us. As someone who advocates for open source technology, I appreciate you not only sharing this as an open source tool, but also taking the time to demonstrate its multiple use cases throughout your presentation. And thank you to the PyLadies audience. Stay tuned for more great talks coming up.